Okay, this is 2013 BC, question number 1. It is calculator active. So I'll call this the gravel problem. So in here, it's a rate problem, and we have unprocessed gravel arriving at a processing plant, and that is given by this G of T equation. So the first thing I would probably do is, in my calculator, I would go ahead and put that into my y equals, and then make sure that's all typed in there correctly. Again, calculator's in radian mode for the whole BC exam. So I would put that in there to start. And then it says that the plant has 500 tons of unprocessed gravel at the beginning of the day, and it is processing at a constant rate of 100 tons per hour. So one thing that's interesting in this problem that I would probably note is that G of T is not the amount of gravel. It's the amount that's arriving to the plant. It's actually a rate. So G of T is the rate in tons per hour that gravel is arriving. So kind of picture it like you have a giant pile of 500 tons at the beginning of the day, and then you have it's being processed at 100 tons per hour, but meanwhile, more gravel is arriving. So that's the situation we're at now. And then it says, find G prime of 5 using correct units. Well, since that is already in my y equals, and it's asking me to find the derivative, the easiest way to do this, and I'll show you a new calculator trick here. So it's going to be a Math 8 problem, and it's the derivative with respect to x. And then here's kind of a shortcut. We used to hit vars and y vars, that's fine, but alpha and then the trace key will actually bring up this screen, and we want it to take the derivative of what's in your y1, and we want it to evaluate that at 5. And then you just hit enter, and voila, you have your derivative. Okay, so that negative 24.588 number, right, would be my answer for part A. Okay, so we've got that's negative, this pen is dying, 24.588 via Math 8. And what does that represent? Remember, I always say nuts, noun, unit, and time. So, at t equals 5, okay, the rate at which the gravel is arriving to the plant, right, we took the derivative of what's arriving, the amount arriving to the plant, right, the amount arriving is decreasing. That's where that negative comes into play. The amount arriving to the plant is decreasing by 24.588 tons per hour, or per hour squared. And that would give you 2 points, I believe, for part A. Okay? So the rate at which the gravel is arriving is decreasing by 24.588 tons per hour at t equals 5. Okay. Then moving on to part B. So find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Okay, so I want to know, it's not saying like the total amount altogether taking into account what's being processed. It's just asking for how much arrives. So that's just going to be the integral from 0 to 8 of that G of T, okay? So it's only asking me about how much is arriving throughout the day. So on my calculator, you can go ahead, and that's going to be a Math 9. And we're going to go from 0 to 8. And again, that little shortcut is alpha and then the trace key. That's a shortcut instead of the vars. And then you could arrow over. We're doing that with respect to x. And my calculator's thinking about it, and it spit out that 800 number. So I've got that equals 825.551. Now think about the units there. So if I was in tons per hour, right, and now I'm integrating tons per hour, that's going to take me back to tons, okay? So I have that many tons are there. And that was worth an additional 2 points, a point for the integral and a point for the answer. Okay, so then in part C, is the amount of unprocessed gravel increasing or decreasing at t equals 5? So we're going back to t equals 5. Show the work that leads to your answer. So this is a little more in depth because we're trying to take into account like all the things that are going on. including the amount being processed and the amount that is arriving. So the way that I kind of saw it is I had to take into account what's going on at t equals 5 as far as what's being processed, right? So the amount processed, okay, is a constant and it's given. So the amount processed equals 100, and that was like tons per hour, okay? Then also at time 5, the amount arriving, okay, the amount arriving is going to be given to us by G of 5. Notice that what they gave us was the amount arriving. That G of T was for how much is arriving. So what I want to do here is compare. Like, is my pile overall getting bigger or smaller? Is the amount being processed bigger or less than the amount arriving? So I have to figure out what G of 5 is. So again, you could do this on your calculator. The thing you might need to do is adjust your window, okay? So I'm back here. If I graph this, it's probably going to look pretty terrible, so I might adjust my window. My X max, I would go to 10 maybe, because it says from 0 to 8, so I would maybe go to 10. And then if I graph that, a zoom fit might not be a bad option here if you kind of do this and you're not seeing the graph, okay, because my Y values here are pretty low. Remember, you can always pause your calculator. When it's thinking like this, it's not going to let you do anything, but if you hit on, that'll pause your calculator and it'll let you to adjust. So zoom, and then option 0 is zoom fit. That might be a better option here for your calculator to kind of think about it. And you can kind of see the graph coming in slowly. So what I want to do is get the value of G of 5. So you could have just plugged in 5 into that original equation as well and just done it algebraically, but I like to let my calculator do the work. So I'm going to do second and then trace and value. So then I plug this in, and I want to know what's going on at x equals 5. And my calculator spits back this 98.141, okay? So I'm just going to grab that from there. This was 98.141, and that's, again, in tons per hour. So what I'm really trying to do here is compare. Since the amount being processed is 100 tons per hour, and at t equals 5, the amount arriving is 98, okay? You're processing slightly more than is arriving, okay? So since more gravel is being processed than is arriving, the overall amount of gravel is decreasing, right? Like the pile, you can actually kind of start to process some of that 500 tons that you were, that you started with. So here the amount processed, okay, is greater than the amount arriving, okay? And let me just make sure I answered the question there. It says, is the amount of unprocessed arriving at the plant increasing or decreasing? So you would say the amount of unprocessed gravel is decreasing, right? The overall pile is getting smaller, okay? So it is decreasing, okay? And that was worth also 2 points. So far, these were each worth 2 points for those of you trying to kind of get your point breakdown. Okay, had to get a fresh sheet of paper there. What is the maximum amount of unprocessed gravel at the plant during the hours of operation? So for this, we need to kind of take into account a lot of things going on. So I said that the amount, okay, so the amount of gravel at any time, we need to write an equation for the amount of gravel. And then, since I'm trying to find the maximum, then I'm going to have to take the derivative of that equation, because we know that a maximum occurs at a critical value, specifically when the derivative goes from positive to negative is where you're going to have a max. So first I need to come up with an equation, then I need to take the derivative of it, and then confirm that it is indeed a maximum and not a minimum by analyzing that, okay? So, all right, what's going on? So the amount of gravel at the plant at any time. Well, we started with 500, right? So then it's going to be plus however much arrives minus how much I'm processing. So that's going to be the integral, right? Because we're given the rate of G of T, but then keep in mind, from that amount arriving, we need to subtract 100 tons per hour, because that is what's kind of being processed throughout the day. And since I'm going to take the derivative of this, that's actually great news, because when I take the derivative of the integral, right, these just turn into x's, okay? So because I'm trying to find the maximum, I take the derivative, okay? And the derivative of 500 is 0. When I take the derivative of the integral, right, that's just going to be g of t and minus 100, right? Because the derivative of this just gives me what's left to the right-hand side there. So I've got this as my derivative, and I want to set that derivative equal to 0 to find the critical value, Okay, so a couple different ways you can do that. You could, in your y equals, right, you could just do this minus 100. That's probably what I would do, is I would turn my calculator back on here, and then I'd go back to my y equals, and then on my y2, I would probably just say alpha, and then the trace key. I'd say my y2 is going to be y1 minus 100. And then since I'm only concerned about that, I'd probably go up here to my y1 and maybe turn that off by hitting enter on the equal sign. So now when I graph this, okay, when I graph it, it might take it a minute, but now I'm going to be able to do that, and I'm going to be concerned for where that equals 100. If it was helpful to you, you could also graph the line y equals 0 and do second calc intersect. But remember, a maximum, okay, occurs when your derivative goes from positive to negative, right? So I'm really looking, because think about a sign chart, right? A sign chart, when this goes from positive to negative, that means that the original function was going from increasing to decreasing, and so then you have a maximum there, right? So I'm trying to figure out at what time does that occur. So on this graph here, I'm not so much concerned about this derivative, this 0 up here. I want to know where it goes from positive to negative. So I'm concerned about that t value, or that x value right there. So you could do second calc, and you could do intersect if you also graphed the line y equals 0, but I didn't, so I have to do zeros. And so yeah, I just go a little to the left of it and hit enter, go to the right of it and hit enter twice, and that occurs at the x value of that 4.923. So this occurs at 4.923, okay? And so I did that. Now, just be careful there, though. I didn't really answer the full question yet, okay? This was worth 3 points. So considering where the derivative equals to 0 got you a point, keeping in mind that you already had to establish the amount equation there. And now I need to actually answer the question, because it says, what is the maximum amount? So you then need to take this 4.9, and you need to go back and plug it in up there, okay? So once you do that, and again, your calculator can help you with that, so you're going to have something like 500 plus, and then when you plug that 4.9 in, okay, it's going to be a math 8 again, or I'm sorry, a math 9 again. So you're going to do from 0 to 4.92348. Oh, again, I'm not rounding until the very end, so I use that full 4 point whatever decimal. And I'm just integrating. This time it was my alpha. Mine is in my y2, because I want it doing the one with the minus 100 in it. So I have that in my y2. And I get 135 there. Don't forget to go back and add this 500, so plus 500 there. So that 635 number is my final answer. Okay, so that 635 is my final answer. It is in tons. And again, now I already kind of said up here that this is the maximum. I would still put some sort of a concluding statement there. This is the maximum because the derivative goes from positive to negative, or something like that. You remember, a sign chart is not justification on the AP exam without a concluding statement. So be sure you kind of add in that concluding statement, and that should get you all of your points. And look at that, we did it in under 15 minutes. Good job.